And every half an hour, I'll be asking if anyone has having doubts, so we can go through your doubts one by one. And would like to prefer that everyone can put your mic on mute so that there will be no disturbance for the others. Okay, so let's start. So first of all, good evening to everyone, and thank you for joining us as we dwell into this world of process simulation, a field that underpins countless industries and provides a multitude of career paths. Today, we will explore the crucial role of process simulation and its impact on the various industries. If you can see, every now and then you must be heard the word of digital transformation here and there, digital twins here and there in the many industries. So today we'll go through each of this concept and how it is important for your career paths, be it you are a student or a professional or experienced professional, or you are about to start your journey as a professional in chemical industries. The digital twins and the simulations are must have nowadays in this today's environment. So let's start. So first of all, the each and every chemical industries nowadays are going through a digital transformation with the help of the digital twins. So, what are basically the digital twins? These are the exact replicas of the physical processes that are taking place in the field. And these are revolution, means they are changing the dynamics on how the chemical industries are getting produced and optimizing your process parts. So, by leveraging this real time data, and followed with some data science advanced analytical tools, digital twins are helping in many countless opportunities in the chemical industries. For example, they can be helpful in the predictive maintenance. Means, for example, if your compressor is getting tripped, for example, it is getting tripped for 5 to 6 times in a 6 months. So then, with the help of simulation models, we are getting the process parameters. We are simulating the process parameters, and also with the advance of the analytics, we are seeing that how frequently, what is the mean time between the failure, why it is getting tripped. Some parameters will have some correlation matrix with each other. So in a way, it is helpful in predictive maintenance also. Process optimization. So if a panel engineer is having a what you can say a digital twin, before taking an important trial in a real time basis on the physical assets, he can first of all trial on the digital twins, that what will be my process parameters if I change certain variables. For example, if I change my temperature from 1 to for example 84 to 86 degrees Celsius, then what will be my reactor condition? Will it be making me conversion more, or will the productivity will increase? So that kind of studies can also take place in the digital twin, which will help in the process optimization. Another is the improved product quality. For example, there will be ammonia plants, polymer plants, methanol plants, several crude plants. So by implementing this real-time data analysis and the digital twins, we can improve the product quality. For example, if a certain variable, for example, let's say the pressure, if the pressure is fluctuating between 21 to 24, but you are getting the best product quality at 23 kg per centimeter square gauge. So then this model will help to finalize that, okay, 23, you are getting a very good product quality. So then you will try to implement those kind of recommendation into your real process, thereby increasing your product quality. So this presentation will explore more on the power of digital twins in revolutionizing the chemical industries. So basically, what are the digital twins? Those are the virtual models that exactly mirror the physical assets, capturing their behavior, performance, and characteristics in real time. For example, if you have a VGO-HD hydrotreater plant, so a digital twin model will be something which is exact replica of your hydrotreater plant. It will be having a CO2 absorber, it will having a furnace, it will have a reactor with a 3-bed catalyst. So exact replica of your hydrotreater plants, they will represent, and how they are being developed by with the help of simulation softwares. So they are created by combining your sensor data. Sensor data means whatever the data is coming from your instrumentation in your plant. There will be a temperature transmitter, pressure gauge. Those will send your data to this simulation software, and this software combined with your machine learning algorithms and the techniques, it will give you the desired results. Digital twins will also enable to monitor and analyze the performance of equipment. So for example, let's say there will be a exchanger. So by regular monitoring, day-to-day monitoring of your equipment, the digital twins, what will it will help you is indicating how your heat transfer coefficient is there. Is there any fouling prediction? If your exchanger is fouling, then what is the percentage of fouling? How you can avoid the fouling by tweaking the parameters, by optimizing your parameters. For example, if your velocity is too high, it may lead to erosion or vibration in your exchanger. So those kind of analysis can also take place in digital twins. Then you can have a prediction failures. Before failure, you can predict that, okay, this equipment is going to fail. So then you can plan your shutdown, or if there is a standby equipment, you can take the standby equipment in line, and then you can have a maintenance on this equipment and try to analyze that which are the parameters which can enhancing the failures, so that you can avoid those operating windows. Then you can also optimize the processes. So by simulating this kind of various scenarios, engineers can make these data-driven decisions to improve the overall efficiency, and thereby you can also have a profit improvement opportunities, that is reducing the cost. Till here, anyone is having doubts? Okay. So what are the benefits? So as we explained you that it is helpful in predictive maintenance. Right now, uh, since I am having a 12 years of experience, and I have seen this digital twins of the predictive maintenance scenarios. It is the, I think, most lucrative option that most of the industries are implementing. Because if you can see na, in a plant, the majority of your equipments are failing, or having a high cost of spares, and because of not operating in a best operating zone, you are having a failure, and that equipment is not able to perform in a very good shape. So predictive maintenance is the majority of this, along with your process knowledge. This is the icing on the cake, and it is helping the industries to crores of annum profit, and it is helping industries in a very mind-blowing way. So you can also see, if you have implemented the predictive maintenance part, so obviously you can reduce the downtime of your equipment. For example, there is one exchanger, and after every 6 months that exchanger is getting fouled. So you are having a model of that exchanger, and with the help of digital twins, you see that at 170 degrees Celsius, this exchanger is having a heavy fouling, and and the fouling is increasing like 1% every day. So you are then optimizing the temperature to 155, and that fouling has been reduced. So that shutdown, which is going to take place at every 6 months, is now prolonged, and you can run your plant for another 3 months. So that 3 months of your time is your, that 3 months is something where you have a profit that you have run for another 3 months, and that profit is for with the company. And maximizing the asset utilization. Asset utilization is something that whatever equipment you are having in your plant, is it performing to its best? Is it performing to your design level? Or is it performing to the maximum level possible? So that kind of uh, case studies or projects are being done with the help of digital twins. Another is the real-time monitoring and analytics. See, whenever if you work in a if you are working or work in chemical industries, every day you have to release a plant performance monitoring report, that how your plant has performed on a daily basis. So this kind of real monitoring data and analytics will help in identifying the efficiencies or the inefficient equipments which are there in your plant, and then you can work on it along with the instruments and maintenance department, and then you can try to figure out that okay, this equipment is not working properly and we have to look into that matter. So how you will know? You will know it if you see manually. There must be in a plant around 200 to 300 tags, so it is very difficult to find out in a manual day-to-day basis with the help of Excel. So this kind of digital twin models will help you in maximizing the process efficiencies, and that can be lead to improved productivity and reduction of your waste. Digital twins also facilitate the rapid prototyping and virtual testing, accelerating innovation and time to market. For example, if you um, if I say the polymer industries, and if you want to try new grade or new product into your reactor, so before taking that product to the market, you want to see that how it is being tested on a field. So that kind of digital twin will help you that okay, you have taken a trial on the digital part, and then you can see that whether you are getting the best results or not. That way you can virtually test that part, and thereby you can accelerate your innovation, and you can also capture the market. So, by harnessing the power of digital twins, chemical companies can achieve higher operational efficiency and drive their sustainable growth. Till here, is anyone is having doubts? Please feel to ask.
Ma'am, we had a request to elaborate on digital twins. Like,
Okay. Yes.
yes.
So basically, first of all, I'll explain that what is the difference between the simulation and digital twin. Okay. So simulation software, if you see, it is something that you will manually uh, uh, do the modeling, for example, of a compressor or of a plant, and then you manually put the data of input and output streams. What are the process conditions of that streams? And then you will know what kind of results you will be there. So there is no input of real-time data in the simulation, because that is the manual activity which individual will do. Now, what digital twins are doing is that same particular model of simulation. What they are doing is, for example, compressor only, we can say. We can go through here. Yes. So for the compressor, so what are the input conditions which will be providing in the digital twin is the temperature, pressure, composition of your streams. So those all kind of information they will take directly from the plant with the help of your instruments. That is pressure transmitter, temperature transmitter, or the analyzers of your plant, and then they will feed directly to the model of your compressor, and then they will run it. That what is the efficiency of that compressor, and based on that performance curve given by the vendor, you will know that what is the efficiency, and then thereby you can take the action that okay, I have to reduce my density, for example. Then you will decrease some of the components or composition which you can try to optimize by maximizing your compressor efficiency. So then whatever the performance or characteristic that you are getting from those kind of models, along with your digital analytics, that is statistical analytics. For example, it will show you the chart of your efficiency, that okay, yesterday it was performing at 70 percentage, today it will be performing at around 72 percentage. So what are the changes that you have done, how you are getting higher performance, or why you are getting the lower performance. So this is how the digital twin will take place. For example, your Aspen model, the Aspen model of your compressor, along with the real feeding of your real-time data from directly from the plant. And that model will run in the background on an day-to-day basis, and then it will provide you all the analytics which is required in order to optimize that equipment. I hope I am clear. So basically, digital twins is nothing but it is taking all the real-time data. Real-time means which is going on your plant, real-time data of your plant, indications, temperature, pressure, composition, anything that you want, and running it on a simulation model, behaving exactly as your real plant, physical asset, exactly like that, but on a simulation model. And then it will provide that, okay, by tweaking your temperature or by increasing your temperature, you can further optimize this process. These are known as the digital twins. I hope I'm clear. If anyone is having doubt, they can ask.
No, ma'am.
Okay.
No, ma'am. No.
Okay. Okay. I hope I'm clear about digital twins.
Yes, ma'am.
Okay. So what are the challenges? And because see, if you want to prepare a digital twin in your plant, then the problem with this is that first of all, you need to have proper sensors in your plant. For example, if you are having a plant which is 40 years old, then obviously you do not have good sensors, means accurate sensors in the DCS. So first of all, you always require each and every sensor elements coming to the DCS. Then from the DCS, that is distributed control system. So from that DCS system, then only you'll be able to, use that into your digital twin software. So that kind of sensor should be there in order to model that kind of digital twin. So first of all, it requires a significant investment in sensor and the data infrastructure. So obviously data, anything that now you do, data is the master. So if you do not provide the data, then how you will be able to do the analytics, first of all, on manual basis also. So data infrastructure is the biggest investment that a company can do, and providing better sensors at each and every location, which can help plant to further optimize its performance. So these are some of the challenges. If your plant is very old, you will not get proper sensors. They are not calibrated, or they are not in the DCS system. So those kind of things that you can face. But I think most of the companies nowadays, which are 15, 20 years old, are having a very good sensor capability and data infrastructure. And the another issue with respect to this is the data privacy and the security concerns, because this kind of systems works on a firewall and it cannot be connected with the outer data. So anytime if data breach happens or hacking happens, then it can go haywire. So this kind of scenarios can take place. So if you have a data infrastructure, then obviously you have to provide that security to your data. So these are the some of the challenges. Another is the integrating digital twin with existing legacy system can be a complex. Means obviously, for example, if you simulate whole plant, for example, compressor hai, then there is a separator, distillation columns. So small equipment and small unit, it is very easy to do a simulation. But when you do for a proper plant, then it's get difficult. And in order to have exact replica of the physical system, it is even more difficult. Why? Because you have to be very concise, very accurate in data providing, so that your digital twins will give you the exact outcome which physical system is providing. So that kind of what you can say, capability development of engineers is something an issue in the industry. I think that's why many companies are now providing the encouraging young people to take up the simulation or digital twin courses so that they can upskill themselves into this. So this is something that can be the challenge. Also, by partnering with technology providers, so whatever plans you are having, your technology providers has a best results data. For example, let's say Catalyst. So Catalyst, apart from your main reaction, it can also have a side reactions. So if you are not having that kind of knowledge of side reaction, you will not be able to accurately develop a proper simulation model or a digital twin. So, by getting the support from the technology provider, you can get that, okay, the side reactions are also take place. So you can add those kind of side reaction into your simulation model, and then you can have an exact replica of your physical system, and you can optimize that perfectly. So these are some of the things where industries or person can um, work upon, and then they can fully utilize the full potential of digital twins in the chemical industries. So, case studies is digital twins in action. Currently, digital twin kind of environment, or you can say there are separate departments in several chemical companies such as Reliance Industries, public sector units such as BPCL, HPCL. They have another department which is working in developing this digital twin. Niara, which is earlier known as SR. Ingenero is working on this dashboards and developing those simulation softwares. ExxonMobil, obviously, they are more into this predictive maintenance part, failure analysis, how they can, make their compressor more efficient. UOP design companies so have already embraced this kind of digital twins to drive the innovation and optimize the operations. See, the technology providers like UOP, they are also using this kind of digital twins so that whenever, for example, like 5 years ago, they have developed a plant. Okay. But now, by developing digital twin model, they have tested that by changing this kind of hydraulics in their design, they can have a more efficiency with the same output. So whenever a new company will come to them for the new project, they will give them the updated data or updated design details. So this way, the design companies are also more towards the digitalization and the digital twins. So we have already seen the already explained the case studies, like for example, like predictive maintenance and improved process efficiency and the product quality. But it also has like how you can optimize the chemical reaction. Even zero point 0.5 or zero point 0.3 or 1 degree Celsius of change can give you significant increase in your conversion ratios, or even certain analysis of your data on a long term scale. Then you can also see that how your equipment is getting failed. And energy consumption. See, nowadays in today's environment, each and every chemical industries are moving towards net carbon zero. Okay, so how they can achieve the net carbon zero is by reducing the carbon dioxide emissions. And how they can do is by reducing the energy consumption in their plants. And how you will know that this compressor can run on reduced energy, or if certain compressor is running on HP steam of 200 ton, if you increase, for example, 180 ton, then also there is no issue with respect to compressor efficiency. So that 2 ton per hour multiplied by 24 multiplied by 365 days. So how many tons of energy you have optimized or reduced, converting that into carbon dioxide equivalent. So that kind of carbon dioxide reduction or emissions that you have done. So these are some of the major hot topics currently going on, and in that mostly mostly all the engineers are relying on the simulation and the digital twins. So if you see that how important it is for a person to have a knowledge of your simulation softwares. So this real world application, so that there are several tangible benefits of this digital twins, and it serves as an inspiration for other chemical industries also to embrace this transformative technology. Is anyone is having doubt? Okay. So hereby digital twins has the full potential to revolutionize the chemical industry by unleashing the power of real-time data, advanced analytics, and simulation. By predictive maintenance, process optimization, and innovation. So I think this is something which each and every industry is leveraging. They are developing engineers. They want to hire those kind of engineers into their plants, which are having knowledge of the simulation softwares, because more and more they want to rely on person specific decision less, and they want to move towards the like digitalization, because see, person can make a human error, but the digital twins or the models will, there are tendency to have a very less errors. So those kind of drives are going on in the industry, so it is very essential to one to have this kind of skills in their uh, you know set of skills which they have acquired. So this is really important and very much necessary nowadays. So, is anyone is having doubt in this? Please feel free to ask any kind of questions that you want to ask in this.
Hello, ma'am.
Yes.
What are the fees for this course?
Pardon?
If I want to learn this process simulations for twins, then how much fees?
How much?
Sorry, yeah, that we will cover up in the later portion.
Yes.
First we
Yes.
will discuss the
What are the career opportunities? Yes.
yes.
Those we have this presentation on that part as well. That what Chem Club is providing and how you can gain this kind of knowledge also. So we will cover that on a later part. Anyone is having doubt with respect to digital twin can ask me.
Hello. One question, ma'am.
Yes.
Uh, whether we are, can you uh, give us one example with proper example that how this uh, this is working with one of the example?
Sure. See, for example, uh, nowadays, uh, if you see, I think in the gasification unit, for example, I'll give you the gasification unit. So in the gasifiers, coal gasifiers, coke, pet coke gasifiers, there are multiple gasifiers. For example, there are three gasifiers, and they are very high maintenance plant because they are dealing with the coke and it is dealing with the solid particles. So every now and then, every month, each gasifier is down with some or other related issues. So there was this, case study on this gasifiers, that how they can reduce the downtime so that maximize that gasifier asset utilization, and then they can produce the syngas, which is from the water gas shift reaction, if you see. So then they did a real-time analysis of that model, and they find out that when they mix certain kind of slurry, like there will be a pet coke slurry, okay? So if that slurry percentage is higher side or lower side, then they are facing the issue with respect to filters down just after the gasifier. So they try to analyze this. They model the gasifier that at this temperature they are getting the maximum amount of syngas produced. Okay. So with the help of obviously technology provider also. So in a way, now that three gasifiers which was down every month, okay, and then two will be running. Now they are running continuously for about I think 10 to 12 months and generating huge amount of profits. Why? Because they uh, implemented a model, digital twin, and some statistical analysis that why certain things are happening in the plant. For example, pressure also in the filter efficiency. So this is the real case scenario. Obviously, developing this kind of model is very difficult. You require in-depth knowledge of that particular technology and your process simulation skills. So this kind of combination will give you the best results. So this is one of the case study that I can tell you, and there are several others case studies. So I hope I was able to answer to your question.
Uh, One question, ma'am. Now
Yes.
we were discussing that real-time data needs to the software to understand the process, and he will give the uh, best solution. So whether this software is needed to install at the time of running plant or a running plant PC, where the DCS or PLC is installed. So this software is needed that time, then only it will fetch the real-time data. Is that any temperature
No,
or
no, no,
pressure parameter is fetching?
no, no, no.
How
See,
things you can guide in that?
yes, yes. See, so whatever your data is coming from the plant, okay, the transmitter data. First of all, it is coming to your mm, server. Okay, from server it is transmitted to the DCS system, that is OPC servers. So from that servers, it is getting to the distributed control system, and you are seeing those data on your panel, which you see. And the panel engineers then deal with this controllers, and then they can change whatever they want in their plant. So this is how normally it works. From DCS system, they go to another server, which is not linked directly to your DCS, because your DCS system will not be, you cannot disturb that system. So those data then fetched into another OPC server, which is connected with the firewall. And that server will provide data to a simulation models, which is running on the real-time basis. So, for example, there are three screens available for the panel engineers. Then one screen will be with this model, where they can see that what kind of model is running, how they are developing the result, and what the results they are getting. So by, understanding this kind of analysis, then they say, okay, now I want to change the temperature. I think my temperature is not giving me the proper conversion. So then he will change it in the DCS system. So this is how the model works at the plant level.
Yeah,
Hello.
understand, ma'am.
Okay.
I have a question, ma'am. So
Yes.
basically, the simulation is different thing, and the digital twins, these are the different things.
See, there is very fine line of difference. Okay. Both are running on simulation softwares, but uh, this which is digital twin simulation software is getting with the help of Python and other languages. So you are involving this simulation with the real-time data analysis on another platform. There are several platforms available, Power BI, Grafana. Okay, there are many platforms available where you can also take consideration of this Aspen models, Aspen or any other HYSYS or Unisym or any platform, any simulation software, and then combining that with your real-time data analysis. So this is
So
the
using
digital twin. With if
so
you
yeah.
merge this with the real time, it becomes the digital twin. And normally what a person do as an engineer is first you develop a perfect model on the simulation. So there you yourself will provide the data in the simulation manually.
Okay.
It will not fetch directly.
Okay. So the first of all, we develop the simulation
Hmm.
and we generate the data
Hmm.
and we making the model like uh, what we said the digital twins.
Huh.
Is
See,
it right?
yes, first I'll tell you. see, first of all, how the workflow will take place. First of all, an engineer will try to develop a plant model as much as accurate as he can in the simulation environment, that is Aspen, HYSYS, or any other simulation software. Okay. So how he will do is he will take all the inputs from the plant, he himself will put it, and he will run the model, and he will check the output with the real plant, whether he is getting the same outputs or not. If he is not getting the same outputs, that means his model is not accurate. That okay. So first of all, he has to do that kind of fine tuning with the model. So once he has developed that model with the fine tuning, that whatever results he gives, okay, that is matching with the plant. Okay, the same result which is going on in the plant, that result if is putting in the model, that model will give you the same result what is happening in the physical plant. So that level of accuracy is very difficult to achieve. So that accuracy is being achieved by the engineers. So then that model, with the help of Python and SQL servers, is getting deployed in the digital twin environment, where the data which you are provided, which you are providing manually, those are being replaced by the real-time data of your plant. And you know that it was matching with your physical plant. So it will generate the best outputs. So this is how the workflow take place.
Okay, I understood. But my question is, so the digital twins is a software or something like that. The much more one or two more software include there.
No. See, software is something which is Aspen Plus or HYSYS, or these are the software where you do the simulation. Digital twin is the concept. It is name given to this, how you can develop the exact replica of your physical system.
Okay.
Hello,
Yeah,
ma'am.
yeah. Understood. Thank you.
Okay.
Hello.
Yeah. Yes.
Ma'am, digital 4.0 and digital twins are both the same.
Pardon?
Like digital 4.0. And,
Yes, that are one and the same thing. Yes.
okay.
These are something, with the higher integrity, higher level of accuracy. They have named 2.0, 3.0, 4.0. That kind of naming is being done, but the concept is the same.
Okay. Thank you.
Okay. So now we'll move towards the presentation, that is exploring career opportunities as a process simulation engineer. So process simulation, I think, is now bread and butter of a chemical engineer. Now if you have a fundamentals knowledge, if you have process design knowledge, everything is good, best. But if you don't know the process simulation knowledge, then I think it's very difficult nowadays to what you can say, move, like you'll be able to thrive in the environment, but for growth wise, as a growth in a chemical engineering firm, it is not helpful if you don't know the simulation knowledge. So I think each one of you, no matter what, but at least one should have an idea how simulation works, and also have a basic hands-on training that how it is being done, so that whenever in the future, if that kind of roles are appeared or roles are there, then you can surely go for it. And I think see, now today this digital transformation and everything, sustainability, CO2 emission reduction and everything are these all things are connected with this digitalization. So if you see from, I think, down the line after 2-3 years or 5 years, I think this is the essential something which is like, having a bachelorette. This is something which is having, like, you should be knowing. It's not something that you, if you know, then it's okay. But after 3 to 4 years, it is compulsory to have the knowledge of process simulation. So let's go into that slide. So this presentation will explore about the various career opportunities which are there in the field. We will also go through some of the skills and industries, how you can utilize and potential for the growth and innovation. So what is process simulation engineering? So it involves using the computer models and mathematical algorithms to simulate and optimize the industry processes. This will help in analyze and predict the behavior of your system. And see, the basic uh, motives of both digital twin and process simulation is same, that you want to reduce the cost, okay? You want to increase the process efficiency, you want to increase the process performance. So those are the basic motives which is similar, but the behavior is different. And like, for example, if your compressor is behaving very badly, then you try to simulate this in the, that okay, this is my input stream, this is my pressure, this is my temperature, this is my flow rate, this is my composition, then what can be my discharge pressure, why it is not behaving perfectly. Okay, here is the problem, the recycle valve is opening very frequently and it needs to be stabilized. So this kind of analysis you can do in the process simulation. So industries such as chemical manufacturing industries, any energy industries, power industries also rely on this kind of softwares to optimize their operations. So what are the skills that you required? See, uh, I don't think that uh, I think you require your mindset first. Like, it is something that if you want to, then you can go for it. It's something that you can develop over a period of time. And if you want to learn, you are curious about how this is being done. So I think that is the best, one of the top skills that you must be having, that you should be always curious that why this kind of uh, process is bad. Is there any chance of improvement? Then it is very, very helpful. So obviously you require a strong foundation in your chemical and process engineering principles. Also the proficiency in the software such as Aspen and HYSYS or HDRI, any other simulation software where you can analyze and interpret your data. Additionally, nowadays, along with the simulation softwares, if you have a statistical analysis, that how best you can show your data. See, anyone can produce data in tables in Excel, but I think the top level executives or the management, they don't have time to look at the tables, right? They want to see the graph, that what is happening, why it is happening, and what is the inferences. So they only see the graphs and charts. So this is how the best you can show to them. And that is where your statistical analysis skill will guide you. So these are the most, developing useful skills that one must have in order to thrive in this process simulation engineering role. So which are the industries that are utilizing the process simulation? So the earlier which I have named, all these industries are using the simulation softwares for their plant performance monitoring. So it also include oil and gas, the petrochemical industries, pharmaceuticals, even food and beverage, power generation, environmental engineering. Be it any chemical engineering, they are relying on more on process simulation softwares. So it is, I think, basic thing that one should have a knowledge of it. So these industries will rely on this to optimize their production processes, reduce cost, ensure product quality, and minimize their environmental impact. The last statement of minimizing environmental impact is the hot topic right now going on, and every industries are onto this, that how they can minimize their environmental impact along with the product quality and performance improvement. So what are the career paths one can think of if you have the process simulation knowledge? Okay, so one can go for the process design part. Obviously, this kind of softwares. For example, you have given that the plant that you are working on, that pump is not working properly. So then they say that we want to get a new pump. Which kind of pump you will do? what will be the process scenarios that you can test on. So what you will do, you will open the simulation software, then you will try to design the pump, and you will design a pump in such a way that it can survive in any kind of plant environment, be it extreme, normal, rated conditions, whatever. So this is the way how your process design part will come into picture. And if you go, there are many industries. For example, McDowell is there, McDormand is there, then there is Technip, Technimont. Those kind of design industries are utilizing simulation software heavily. I'm not saying moderately, heavily, and then they are designing their equipments for their upcoming projects. So having knowledge of simulation software will help you in the process design. Then another is the research and development. So pharmaceutical industries, research and development, then petrochemicals, if there is new product development. So R&D, they do heavy analysis in the process simulation softwares. So R&D part also, if you like go for the PhD part or doctorate part, then nowadays simulation knowledge is a very much necessary requirement. So another is the process optimization part, which we already discussed, how you can optimize your process, then day-to-day operations. Then also if you want to have a training and education or your process simulation, then if you want to make a decision making, how decision making will be helpful. For example, there is a closed loop plant, okay, and in that plant there is a system pressure drop. So if that pressure drop goes from 0 to 1, at 1 it will shut down their plant. So then they try to analyze it, that how long this plant can work or it can operate. So then the model that you do in the simulation, it will give you that today it is 0.7, you can still run for 3 to 4 months. So that way they can decision making, that they can plan their shutdown in a very proper way if they know that they are going to shut down before 3 months. So this kind of decision making will also like like process simulation software helps in making the decision perfect about how and when they can take a shutdown. Also, if they want to take a trial of the product or not. So this kind of things are there. Another is the production planning. Yes. See, every year, whenever your plant, for example, methanol plant, so that methanol plant is running. So every year there is a production planning will take place. For example, right now is 2023, right? So for 2024, starting from January to December, they will plan that every month how much production of methanol that they will do, and by consuming how much amount of quantities. So how they will try to optimize with the help of simulation software. So that way your production planning also takes place. So see, these are the like majority of career paths and the growth opportunities that the simulation engineers can have. And nowadays, with increasing emphasis is on sustainability and efficiency, the demand is increasing day by day for the skilled process simulation. Like every time, if you see when we take interviews, this is the, I think, must have skills everywhere. And also this field offers an exciting growth and opportunities whenever in your job. Also, if you have knowledge of this kind of software, then your growth ladder is very good in that particular organization. Is anyone is having doubt?
Ma'am, hello. Ma'am,
Yes.
ma'am, this will useful in oil and gas operation or not? This type of working process.
Pardon? What you're trying to say is that whether this will helpful in oil and gas?
Yes, upstream operations, especially
Explorations.
exploration and drilling and production also. Sorry.
Yes, yes, yes. Very,
Ian.
very, I think I can say very for many times, but very useful. So oil and gas, it is the best thing. See how it will be useful. I'll tell you that there are different kinds of crude grades in your plant, right? For example,
Crude, yeah, right.
you are having different kinds of crude, and how much
Yes.
you will blend in order to get the perfect cut. See, right now, I think most of the companies are not making diesel. They are more into the aviation turbine fuel and petrol. So, what kind of crude will be blended in order to get the maximum petrochemicals out of that crude unit and maximum cut? So, this kind of work is done in the process simulation. So, after simulating and analyzing this knowledge, then they try to select which kind of then they try to take a decision that which crude to be blended together. So this is extremely important. I hope I have clarified your doubt. Okay, here I can give you another case study that see whenever you have plant like they are providing mother plant, you can say, for example, gas cracker, naphtha cracker, or crude unit, which gives the necessary raw materials to the downstream units of their plant. So this kind of uh, mother plant, the process simulation softwares, optimizers, there are other simulation softwares, are very, very, very much useful, because what they can do is they can analyze different feed compositions, and then they can see that they can cater to the downstream plants or not. So the decision making comes into picture. So in those units, in mother plant units, the decision making is the main thing that they work with the help of process simulation softwares. So I think many engineers are working day and night on this only, that which crude to be considered, that they can refine it and get the maximum petrochemicals out of it. Okay, so anyone is having doubts?
Yeah, ma'am. One question from my side.
Yes.
Whatever you are taking the examples, it is all belongs to the petrochemical and oil and gas industries limited. So I just wanted to know, is this process is applicable to the specialty chemical or agrochemical or any pharmaceutical or API industries?
Yes, definitely. Especially for the pharmaceutical industry, product quality is the main emphasis is with respect to using of process simulation, and specialty chemicals are the major things that nowadays they are working. See, specialty chemicals, the quality of the product, like there should be some ranges and composition of that your range of that product should be within that range. For example, PVC polymers, so that melt index or density, it should not vary, else your product quality is down. You will not get the best price. So this simulation software is helping them very, very helpful in analyzing and like minimizing their waste, maximizing their performance, even increasing the conversion ratios also. So specialty chemicals, pharmaceuticals, best means they are as see simulation is nowadays word of all used in each and every industries of chemical engineering. So in agrotech also, if you go for a like nitrogen fertilizers or those kind of industries, it is in ammonia productions, urea productions, the simulation softwares are used. Why? Because see, it is normally all the plants are running with the same equipments, right? Compressors, turbines. So obviously you need to optimize that performance. So it is useful in each and every sector.
Thank you, ma'am. It's quite clear.
Okay.
Hello, ma'am.
Yes, yes.
Yeah, ma'am. Basically in pharmaceutical industries, mostly they are using in for equipment mappings and heat load calculations, agitated power calculations. But compared to oil and gas, the both are similar difference. I think I'm right.
See, somewhat difference will be there, but the utilization is similar. Like, see, in pharmaceuticals, I think production planning uh, is also an issue, issue. So they can consider in using that production planning also. Sometimes in R&D also, if you want to take a trial of a new pharmaceutical products, like for
Yeah.
example, you have instead of 0.1 milligram, if you do 0.2 milligram into that product, what will be your outcome, right? So in that R&D, I think simulation will helpful.
Yeah, like a pilot plant or tech transfer related.
Yes, yes. So that pilot plant also, they can model it in this simulation environment. They can feed the data and they can get that, okay, by feeding this, you can get
Okay.
that kind of product.
Okay. But in the software, we are basic is PNID and PFD is a very basic thing.
Yes, yes. And you can try to, there are many equipments available. Specialty equipments are also there. There are some
Yeah.
customized equipment you can also do based on your laboratory.
Yeah.
You can make your customized equipment also in the simulation softwares.
And once we have to learn for simulation software from our chem club, only online. How can we will physically we have to do some simulation from our system? How it's possible to give a training to our students?
I think we will cover up in this session in after this presentation that thoroughly that what are the certification courses that Chem Club is providing into this simulation.
Yeah, yes, ma'am. But we have to manually we have to simulate some example, some
Yes,
ammonia designing
they
or
provide
whatever.
such type of.
But you, yeah, from you only that showing that how to we have to operate whatever the stuff just to take a class from online only, but we have to simulate from our practical class. How it's possible? Do you have any access to access from our own system?
Access from the system. I think Chem Club will provide you and give you the case studies also and basic skilling also. Jatin, am I right? Okay, I think that part we can park this question to the end of this session, and we will. I'll get back to you in this in detail.
Yeah, yes, ma'am.
Yes,
Because
I think.
we have to read theoretical and what are the steps actually from your teaching like that. But we have to know about that. We have to manually we have to operate that system. Then only we have to know what are the valves, what are the equipments you have to select for this simulation.
Yes. I think that is covered in this
So,
certification courses.
that's why I'm asking.
No. I
Yeah,
think
that's why I'm asking.
yes, that is covered, and you'll be having that kind of knowledge also if you apply for this kind of certification courses. But also we can
Yes.
park this question, and I think Jatin will explain you in detail about this.
Yeah, yes, ma'am.
Okay.
Thank you.
Yes, so in conclusion, process simulation engineers presents a world of possibilities for those seeking a rewarding career ahead. By combining your expertise in engineering along with your plant knowledge, right? See, if you, my thing is very clear. Like, for example, if you are a college student and out of college and you directly go for simulation engineer, I think that is very bad. Before having a simulation, you should be knowing that how to simulate it. But a plant knowledge, basic plant knowledge is very much necessary in order to be a very high performing process simulation engineer. Because unless and until you have not seen the plant, how will you simulate it, right? So that is the basic expertise, that is engineering expertise. Along with your simulation tools knowledge can unlock the potential to optimize your process, solve the complex problems that a plant is having and also drive the innovation. So I think you should also embark this journey of utilizing this full potential as a process simulation engineer. So now we will go through each of this simulation software and application in process engineering one by one. Till here, anyone is having doubt, they can ask me. And if not, then we can go ahead with this presentation. Okay, so now we will go through each of this, in brief, that which are the simulation software and what are their applications. Okay, so what is the simulation modeling? So typically, engineer, if they do it on a manual basis, then it is very difficult to do this kind of simulation. So it is a powerful tool, basically a software tool widely used in all the different types of chemical industries to design the process, to analyze and optimize the process. Also, it can work out the complex calculations. For example, if they say that my steam is coming, but my steam header is facing some issue, it is like steam hammering is going on in the plant. So identify where there is, what is the issue and where it is taking place. Okay, so then you will design whole network of the steam header and then you will try to identify that problem. So that kind of complex calculation can also work out. Then develop a different alternatives and operation scenarios. For example, if I increase the pressure, what will be my outcome? If I increase the temperature, if I change the ethylene composition, what will be the outcome? So this kind of also alternatives you can do. Another is we can also model the unit operations, like small unit. You can also model if you want to see only the heat exchanger. Okay, you can design the heat exchanger, only separator, distillation columns, compressors, only the pumping requirements. So you can also develop small unit operation also in order to optimize that part. So if anyone in the plant will give you this and try to tell you that you do the manual calculation and material balance of this complex, okay, of this process, and give me the results. So obviously, I think you will require 3 to 4 days to solve this manually in Excel, trying to find out each and everything from this particular equipment. But in simulation, you can do it only 1 day, trying to solve this. And you can also change the operating condition also, that for example, if I see that from 45 atmosphere, it is going to 4 atmosphere. What will happen at this heat exchanger, whether it will give me the best results or not, right? So this kind of things that you can do. If this gas separator is operating at 37, 36 instead of 38, what will happen? The net hydrogen will increase or decrease, or my liquid outlet will increase. So depending upon your process objectives, you can then try to optimize it and then you can implement it. And then you can tell the panel engineers, with the help of everyone's support, then try to operate this at 36 degrees Celsius in order to get the more liquid. So this kind of things you can do in a simulation softwares, and you can have final results also. So what does this model mean? See, model is the representation of physical system by a mathematical equation. Model at their best are no more than approximation of a real process. Basically, what is model? This is known as model only. That, okay, in physical also there is a hydrotreater reactor. There is a heat exchanger. Then there is a separator. Then there is a heat exchanger, upstream and downstream. And then there is another reactor. It is already there. What you are doing is you are creating a replica by modeling in this software. And then you are putting the input which are there. For example, this water is coming at 30 degrees Celsius. Then you are putting it 30 degrees Celsius, water is going to this mixture and then it is going to the pump. So this is known as model. See, model can be anything. If you want to, what is your objective? If you want to model only a pump only, then this is only your model. Agar heat exchanger hai, then this is also a model only, if it is a single heat exchanger. So whatever you try to develop in the simulation model in order to optimize their performance, it is known as a model. And equation are based on the fundamental laws of physics. That is your conservation principle, the transport phenomena that you already studied in chemical engineering, thermodynamics, state equation, chemical reaction kinematics, first order hai, second order hai, reactor kya hai, CSTR, plug flow reactor. So all these kind of things are the same. The basic fundamentals of the chemical engineering is the same. Only thing is you are trying to create that at the software level. Okay, so this is means by model. For example, if you want to increase the performance of heat exchanger, then you only put a heat exchanger over here, input output stream you have already established, and then you try to see that what heat exchanger is giving me. So that one heat exchanger is also known as model only. Okay, so this is what a model means. Then what does a simulation means? When you have developed a model and you are solving it, okay, in order to get a output or result, this is known as simulation. So solving the model in equation analytically or numerically, that is known as simulation. So modeling and simulation are valuable tools, and they are safer, also cheaper, because safer is because you are not doing it on real system, right? You are doing it here. You are taking trials, you are experimenting in modeling or simulation environment. So it is no harm. So it is safer and cheaper to perform tests using computer simulation rather than carrying a repetitive experimentations and observation on real system. So in the market, there are different models which are available, and we will go through one by one, each in detail. So there is also Aviva. This is a SimCentral Aviva. SimCentral is the platform where it is being used for process utility. Utility matlab steam, cooling water, power, those kind of things are known as utilities. And flare simulation. Flare means there will always be flare for your plant where you vent off your gases. So SimCentral, Aviva is the normally we say the Aviva simulation software, but it is a SimCentral. So SimCentral is ideal for your chemical process simulation, especially the complex one with having a lot of recycles where conventional simulators perform very slowly. And each platform application uses the same user interference and solution engine so that engineers can perform in the same software environment. It is easy to use optimization tool to optimize your process design, such as finding the ideal plug flow reactor length, integrated dynamic simulation for better distillation column, relief load calculation. So here I want to say that what is static simulation and what is dynamic simulation. So first of all, static simulation is something ki you know that you want to design a pump, okay? You know the input conditions, you want to find out what is the output, okay? तो आपने pump का head दे दिया, input streams दे दिया, and you know, then you run it, the model, and then you will get the output. Now, what is the dynamic simulation? Here in static simulation, you have provided the details only one time, okay? In dynamic, with the change in pressure, okay? For example, if you say like a very common example, I tried to point out, a balloon is there, okay, in your hand. So balloon, there is a balloon filled with air. So then when you open that balloon with a small opening, that air is passing through that small opening, and then slowly it is, the size of the balloon is decreasing. But if you try to increase that opening with the hand, then that gas will went off very quickly and your balloon size will decrease in a very short period of time. So that pressure change, ultimately what you are doing the change in the pressure from small opening to big opening, right? So that pressure change is known as dynamic simulation. So whenever your distillation column is there, okay, so it is trying to vent the gases out of your column. So that gases will try to vent from a control valve. So at control valve inlet, that pressure will decrease with the venting. So that kind of known as dynamic simulation, where your inputs are changing with the flow of your gases. So that is known as dynamic. And then you can find out that what kind of relief load, that how much, what size of PSV, that is process safety valve, that you want to have on your distillation column in order to have a safe margin available. So this kind of things can also be done in the simulation software. Okay. So another is the Pro2 simulation, which is also being provided by the AVEVA. This is being done by for optimizing your plant performance, the design and operational analysis, also performing some engineering studies. This is the replica. This is the software environment. So reactor modeling Pro2 is very good, AVEVA Pro2, where you can do the conversion and equilibrium reactors. Then you can also have model the plug flow, CSTR reactor, shift methanation reactors, boiling point reactor, batch reactor. So basically from the point of view of productivity or plant yields, or in terms of reaction, this is very helpful in modeling that kind of environment. So this is very helpful in monitoring, optimizing plant yield and profitability. Another is the Petrosim. I think this is the petrochemicals and oil and gas are like bread and butter, because it is very easy to use, and it gives very good outputs results also. So Petrosim is the KBC's process simulation software, and very much useful, and it requires very less inputs to get the results, and can provide also results in a very the accuracies are also good. So it is also used for the refinery rigorous modeling, means pura plant you can design in the Petrosim. So HCC reactor, hydrotreater plants, reformers. So it's built to work in real time also. You can try to put the real time also in analysis for monitoring unit health and profitability. It can also have the heat exchanger modeling and HTRI integration. I'll go this in the HTRI slide. So basically your refinery and petrochemical, it has all the necessary equipment. It has a good equation of state, so your model converges very perfectly. So this is, I think, very, very much useful for oil and gas and petrochemical plants. Another is the CAMCAT. This is a small, good to have a software where highly flexible is there, affordable also. Modules work within a single graphical user interface, and you can have a small equipment design, sizing also, heat exchanger, vessels, piping, valves, each and everything. It is same. But the thing is, Petrosim is having more comfortable and equipments related to oil and gas and petrochemicals more than the other softwares. HTRI. See, any heat exchanger, like in the plant, heat exchanger, no one can beat this software in, modeling the exchanger part, because it can also model that how much tube you have plugged. Sometimes, in the plant, your tubes gets pass, and then that tubes you need to plug. So you can also see the heat exchanger performance with the tube plugs also. So it is very, very detailed oriented, and majority of your times you have margin in heat exchanger performance only. Like you can, change some of the parameters, and then you can achieve very good performance in your plant with the help of exchangers. So HDRI has developed a heat exchanger modeling only, where you can only model heat exchanger only. Different types of heat exchanger you can model here. Very, very flexible, rigorous specification. You can also design that what kind of exchanger you can design. You can rate it. Very useful for heat transfer equipments. And I think majority of the design companies and the refineries and petrochemicals, oil and gas, they are using HDRI for heat transfer for the exchanger modeling. And here I have said that Petrosim allows for HDRI integration. So as I said that exchanger modeling mein no one can beat HDRI, right? So Petrosim what they have done is that whenever they design a plant, whenever there is a heat exchanger, they can integrate both the software. कि heat exchanger के लिए HDRI use कर लिया, बाकी के लिए Petrosim. So they can integrate that kind of thing also in the Petrosim. Aspen also it is possible likewise. So this is all about the HDRI part. Another is the Aspen Plus. This is the basic user interference of Aspen Plus. I think Petrosim and Aspen Plus are the most common used simulation software. Aspen Plus is having a very, flexibility. Like for example, Petrosim can only work in the petrochemical and oil and gas, but Aspen Plus can work in each kind of environment, be it a specialty chemicals or fertilizers industries or pharma. This is, I think, very, very having versatility of, you can see the simulation software covering the wide range of operations. So this is the significant advantage of Aspen Plus. And most used simulation software in chemical industries for steady state simulation, rigorous column design, hydraulic calculation that you want to do for a pump, then existing database of species of it have a very good library, in order to simulate each kind of different processes. You can also try to model the polymer, electrolytes, solids for the batch and continuous operations. It can also handle very complex processes such as multiple column separation, chemical reactor, distillation, electrolytes, reactors, be it anything. It can model anything. So very commonly used software, Aspen Plus. Another is Aspen HYSYS. So this Aspen Plus, where I said that static, that is steady state simulation, but HYSYS you can also do the dynamic simulation also. That is the only difference. This is most suited for oil and gas industries. Inbuilt templates are also available where you already have equipments for blowdown analysis, PSV sizing, safety analysis, refinery units. So those kind of reactor modelings you can do. Then there is a detailed pipe hydraulic calculation. You can also perform in Aspen HYSYS. Then there is an Aspen EDR. Similar to what HDR is providing, Aspen team also, released a software to design a heat exchanger for only heat exchanger for design simulation, rating and checking, finding the fouling. But I think mostly nowadays, people are using HDRI only instead of this Aspen EDR. Another is the Honeywell Unisim. Unisim models are something which you can see in used in operator training, that is OTS, operator training system. So whenever there is a hiring takes place for a plant, so in order to run the panel engineers go through this operator training model where you can simulate the condition key. It can see, this is something where you can add, okay, you put the input variables and then it will give you the output. So what Unisim does that you will say that after like 1 hour, you increase the temperature of this to 5 degrees Celsius. And you know that what are the correct step to, make the process steady. So then that steps are already implemented in this Unisim model. So that operator needs to take that particular steps. So that way he can learn that how to operate a DCS panel of that particular plant. So these are useful in those kind of training models. So it can also be used for dynamic studies also. Then there are simulation software that is very similar to the Aspen HYSYS. So this is the Honeywell Unisim. So why we should start learning the simulation software? First step is to kickstart your career as a process engineer. Then you can master your domain. You can optimize your chemical processes. And there are multiple opportunities available in MNCs, okay, and also in the PSUs also if you have this kind of knowledge. Then you have increased chance of getting shortlisted in the jobs that you have applied if you have this kind of skill set. Then there are many advantages. It can save time, it can save human error. You can try to have better designs if you are in the design industries. So size, types, dimensions, duties. So you can also use the what if scenarios also, that what kind of things you can do in the simulation models. So that's it. Now you can have your questions related to this simulation software. Anyone is having questions?
Anyone, any questions regarding the technology and digital twin, anything?
Please feel free to ask any doubts you have.
Any career guidance point of view also you need to ask, you can ask.
Hello. Hello.
Yes. Yes.
How digital twin is different from simulation? You have explained it earlier, but we couldn't get it.
Yes. So see, I'll go through this slide. So in this simulation software, you are
And
inputting.
how to use and how get digital twin after using a simulation software.
Yes, yes. So see, first of all is that what we do in a simulation software. So in a simulation software, if I want to model this particular unit, okay, then I'll put this equipment, develop a flow sheet, then I'll give the necessary inputs to this exchanges and everything at an every step. Okay. For example, here I'll mention what is the flow rate, what is the temperature and pressure. So then by running the simulation, it will tell me that this will be the output based on the condition that you have mentioned over here. So this is the simulation, how it works. In digital twin, what it will be do, this whole model, okay, this is being placed into a platform, another platform. Same model will be used, okay, because the accuracy of model will determine the output of your digital twin. So instead of parameters where I am putting it, it will be taken directly from the plant and it will be run after it will fetch the details from directly from the plant.
How will hello our plant how will it be the requirement
How
for
it will
fetching
be
the data?
see fetched में क्या रहता है? See that data, as I also mentioned earlier also, whenever your sensor is having your data, it goes to the server and then it goes to the DCS network, that is distributed control system, DCS. From DCS, it goes to another server, which is protected with the firewall so that there is no issue with the DCS system. It goes to the OPC server. So from that OPC server, all the data which is required for your simulation software is being fed from that server to your simulation software. And see, this software is being used at another platform. For example, Grafana is there. Then there are other platforms with the help of SQL servers, and also there is a for the visualization part, Power BI is also being used. So by using those input to each and every equipment, see, you have already tried to model it, you have made it accurate. It is not like that you have input all your parameters so it will run perfectly what is your physical plant is giving. You have to fine tune this. How you will fine tune? By giving the proper property analysis, by giving the property state of art, state of equation, Peng Robinson use करना है या BWR use करना है. So that way you will try to fine tune this model. So after fine tuning it, you will put it into the other platform. From that OPC server, those kind of details is being fetched by the model. It is being run and it can develop, it can generate this model into your another dashboard, which is being there, which can, you can monitor it.
It means that we can get data from plant OPC servers, and as well as we can put our simulation model into this digital twin system. Is it that?
Yes, yes.
So in initial this stage of design, after perfectly near to perfectly simulating the process, we can put this into your digital twin,
Yes,
and
yes.
we will get accurate results. That is what I
See,
understand.
digital twin is every time, real time basis. Like whenever you see, you will get the result. Simulation is when you will put the data, then only it will give. But the foundation is the same. The same model is being used. Only is how you give the input. If you give it a simulation software, if it is directly fetched from the plant, real time basis, it is digital twin. But this model, this you will develop by the engineers, right? Because without model, how it will run? Digital twin. So this model is being done. First of all, it is being like performed या tested कि अगर मैंने ये इनपुट डाला है तो आउटपुट मेरा प्लांट से मैच हो रहा है या नहीं हो रहा है with the same inputs. So this kind of details you have to fine tune this model. Then only you will put into digital twin. Otherwise it is no use, no? Then it will not be the digital twin. Digital twin नाम कैसा है? Digitally you are producing a twin plant, exactly same as the physical plant. I think it is clear.
Yes, okay.
Okay. Is anyone is having doubt?
Hello.
Yes.
Actually, I'm a chemical engineer working in a production plant in pharmaceutical industry. Just I want to change my career in process engineering. Actually, what are the qualities or skills what I want to learn first, because I don't have any idea about that.
You want to move ahead in which sector?
Like a equipment design.
Equipment designing. Okay.
Yeah.
So for the design, I think these are the simulation software that each and every industries, if you see, if you go in ExxonMobil or UOP, they are heavily relying on Aspen HYSYS, Aspen Plus, HDRI, then column designing, pump designing. So I think these are the hands-on training that you can do in the simulation knowledge. Also, you can go through some of the basic thumb rules of the process design, that what are the thumb rules of each and every technology. I think UOP uses some different thumb rules and ExxonMobil use a different kind of thumb rules. So there is a book in process design, thumb rules for chemical engineers in process design. You can go through that, and then you can, try to develop the design on your own in the simulation software, and then you can have, you can develop that confidence. So that I think are some of the skill set that you can have apart from the foundation knowledge.
Yeah, okay. Thank you.
Okay. So
So
I think yes, Jatin, there
yeah,
was one doubt related to this
yes, yes.
certification. So you can go through that.
Yeah. So again, like as the expert told us, the software. So KM Club India, we as a you know the process design engineering consultant firm, we provide different training programs to chemical engineers as well as the working professionals or the students who are willing to change their career or want to equip themselves in the domain of a digital twin or any you know um, new technologies. So we are here to provide you this kind of knowledge as well as the skill development training programs which will help you to excel in your career. So who are we? So we are a process design engineering consultant firm, and we provide the majorly services for basic engineering and process modeling and simulation. Also in the, as we saw today in the webinar, the digitalization, the advent of digital twin, as well as the industry 4.0. So we also deliver a solution to help our clients to transform their organization for higher data visualization as well as improving the processes. So we do basic engineering as well as the front end engineering studies. We have the expertise on these subjects as well as we are on process modeling and simulation part. Okay. So for the simulation modeling, we do different kind of steady state and dynamic simulation. So this is the overview of our organization. Talking about the training program, which helps you to switch your career, or if you are in the same domain, if you want to skill up yourself, we provide training programs on different modules. So we have simulation module, we have process engineering as well as the advanced process engineering module, as well as the unit operation or the module of heat exchangers as well as distillation column programs. Okay. So these are the figures that we have achieved till now, like equipping the engineering professionals in like say 2 years. We have provided 4,000. We have trained 4,000 plus students. We have provided training to 8 plus training institutes, as well as we have formed different batches, like 50 plus batches we have successfully ran. And regarding the webinars also, we have conducted 30 plus webinars at different institute as well as the organization. So we have done some projects as well where we have provided training as well as we have done projects for major industry. So anyone who is willing to join any of the program, we have shared, yes, for the webinar we have shared the feedback form here. So I hope everyone has filled, and if you have not filled, please do share us the feedback, because it will help us to understand the requirement of yours. If you are willing to seek or change your career, or you want to skill up yourself as a chemical engineer, so this will help you to excel yourself in the industry, as well as you can be a part of the industry where it is growing at a large scale. Okay. So I hope everyone had a great insights today with the the content that we had shared, and I hope you have learned a lot from ourselves. We hope to get connect with you in the major sessions that we take. We do discuss about this. Listen, yes, sir.
ஆஃப் பண்ண போறீங்களா? இல்ல பாத்துக்கிறேன். நான் ஆஃப் பண்ணிக்கிறேன்.
Okay.
இல்ல இங்க
So I hope everyone might have attended this webinar at a great instant, and we had delivered you a good content today. Please
ஹலோ
fill the feedback form if you have not filled. Yes, sir. Okay. I hope I have shared all the things. You can ask if you have any of the questions.
Hello.
Yes.
Hello, sir.
Yes, sir. Yes.
Yeah, sir. Actually, in most of BTech chemical engineering, we are from production background, but
Okay.
the companies are not considered for production background experienced candidates. Actually, we
Okay.
have 2 to 3 year experience. After we have to learn some course also. They will sometimes not consider. We want to some actually real time. We have to experience in for particular simulation or a process related experience only. They will preferred. So nowadays we have to done this course also. In future, how can we have to uh, prove that we
Okay.
have to cracking that interview. So kind of issues I will lot time I will
Yes.
is
Yes.
faced.
That's a great question that you've asked. Um, ma'am, can you explain it? I can go ahead.
Actually, one more thing also. So last time I will for Technip and KBR also I will try to attend the interview. They will prefer as I have to modulate my CV to process related. So some basics also I have to learn about that, and I will try to convey and convey my about my experience. But they will we have from production background. You are in pharmaceutical experience, but we don't want to pharmaceutical related. You are experienced in simulation or any other process related. They will be preferred like that. They will ignore that any applications. We have to approach them. So once we done our course from our chem club or wherever it is, how can we have to approach in our future any industries? If you
Yes,
give
yes,
some thing
yes.
about.
So I think very valid and good question in the today's time. So after going through this, can you mute your mic? There is a
Yeah,
disturbance.
yeah,
Yes,
yeah. Sorry, ma'am.
yes,
Sorry.
yes. Yes, thank you. So the thing is that after going through this training program, you will get a certifications that you are well versed with this kind of softwares and analysis, and you know the basics that how you can do and how you can proceed. So, like for example, if you want to move ahead in the career and you want to go for KBR kind of companies. So first of all, you have to divert your current production companies to somewhat specialty chemicals or petrochemicals with the help of this training program. Okay, in the same production background only. Then when you divert from the pharmaceuticals to the another specialty chemicals or other industries, and then you can leverage this skill there and try to utilize this simulation software in your day-to-day work. And from there, after 2 to 3 years of experience in your specialty chemicals, then you can apply for the KBR. So अभी क्या problem हो रहा है ना, straight away seeing the production and pharmaceuticals, they are not considering. The thing is like that. So have some knowledge in the specialty chemicals or petrochemicals or oil and gas or refinery whenever you have a chance to appear for that. And then with the help of this training programs, leverage the skills in that particular industry, and then try to then you can move to this design firms, that is KBR and other design companies.
Yes, thank you, ma'am. Thank you.
Yes, yes.
Okay. Anyone have any questions? Yes, I have one chat where I can see like the introduction of the instructors. So yes, we have experienced industry trainers who have specific expertise in the domain where they have over you know 15 to 25 years ranging experience where they are specialized in simulation modeling or process designing, advanced process control. Okay, so this is the kind of background they have, and they are well versed in all the softwares, all the latest technologies that we are, working on in the industry. So I hope I have answered your question. If anyone have any questions, you can ask.
Hello.
Hello, sir.
Yes, sir.
Hello.
I am from
First,
production
the
department.
website.
Hello,
Okay, sir.
can I listen?
Yes.
Yes. I'm from production department. I am having experience in production from last 9 years. I want to move my career from production to process engineering or simulation or this field. So, which course do I prefer first so I switch my career from production
Okay.
to process simulation?
Okay. So, sir, for that, you can connect with us. Our representative will guide you in, very structured manner for, switching your career depending upon your experience. So, apart from this, like I would suggest, you can, as our instructor told, that you can work in your current organization if you try to switch in the, designing domain only with the programs that we have. Okay, you can start with basic, and then you can jump on to simulation softwares, and then you can apply for different organizations.
Okay, sir. Okay.
So, like I hope all of you have filled this form, the feedback form. So, if you are having the interest, we can, get connected with you, and we can share you the necessary information, and then you can join us for, your skill development.
So, Mr. Jatin, I have one question from mind.
Yes, sir.
Mr. Jatin, so I'm basically from chemical engineer and I'm having total 12.5 years of experience in chemical industry. So different in MNCs and Indian groups as well. So if I want to continue in projection field, in if I want to do some additional apart from that my current field, so which course will be the beneficial for me and how it can be the means improve my knowledge or improve my what we can say the chemical engineering background or which is more relevant to the industries, what are particularly the production industries, not the design industries.
So yes, we do have, as I told, we have process design and we have advanced process control, as well as we have process safety programs. So these are the programs will help you to, get the process knowledge, uh, the unit operations knowledge, the control instrumentation, and how the safety is concerned, the industrial safety is concerned, that you can learn from this the three topics that I told. If you don't want to switch in any designing field, if you want, then you can, jump on to the simulation softwares. Yes.
Yeah, clear, quite clear. Fine. Thank you.
Yes. So I hope we do have more questions, or we can wrap up our, today's webinar. So I hope again you had, good insights today from this webinar, and will, get connect if you are planning to join any of the programs. So I'm sure you all have, filled the feedback form. It means a lot for us to, um, so to improvise our services. Sure then. So here we can, conclude our today's webinar. Thank you for being part of this. Have a great evening ahead. Thank you all. Thank you.
Yes, thank you, everyone.
Thank you.
Yeah,
Very
thank you, sir.
thanks, ma'am.
Thank you, sir.
Thank you, ma'am, and
ma'am.
thank you,
Thank you,
sir.
sir.